Hi students, I am continuing the chapter relations and functions, and today I am going to discuss miscellaneous questions, so listen carefully. This is our first question. Find the domain of function f defined by f of x equal to root of 8 minus x plus 1 divided by root of x square minus 4. So, let's start the solution of this question. So in this question, let us take root of 8 minus x is first part of question, and 1 divided by root of x square minus 4 is second part of the question. Okay, so first of all, I am going to find out the first part of the question, and next I am going to find out the next part of the domain of the next part of the question, and we get two interval, and if we get two interval, we need to take common elements of both these two intervals, and that is the value of domain of whole function minus x. So root of 8 minus x, we know that the value is always greater than or equal to 0, right? Or squaring on both sides, we get 8 minus x greater than or equal to 0, and from this we get x8 equal to taking this minus x2 RHS right hand side, we get 8 greater than or equal to positive x, or rearranging this, we can write it as x less than or equal to 8. Okay, so converting this into interval form, we get x less than or equal to 8 means minus interval between minus infinity to 8. Minus infinity is always represented by a open interval, and here a equal is present, so we need to write a closed bracket in the next to 8. Okay, so this is the domain of our first part of the function, root of 8 minus x. Okay, next I am going to take this term of the whole function. Here we know that the root of x square minus 4, the root value is always greater than or equal to 0, but this root of x square minus 4 lies in denominator. So we know that in any fraction value, the denominator cannot be equal to 0, right? So we cannot write equal to term here. I'm going to write root of x square minus 4 is greater than 0. Okay, I hope you understood. Equal to term is not writing here, because if root of x square minus 4 equal to 0, this term is undefined. Okay, so equal to term is neglected. Only I'm going to write root of x square minus 4 is greater than 0. Okay, so next we need to find out the domain of this function. Square rooting on both sides, we square on both sides, we get x square minus 4 greater than 0. From this we get x square, taking this minus 4 to RHS right hand side, it will become positive 4, right? So x we get greater than plus or minus 2, or it can be written as x minus 2 greater than x greater than 2. Okay, x square greater than 4. So taking square root on both sides, we get x on LHS, and root of 4, we know that its value is plus or minus 2. So it can be written as minus 2 less than x less than 2. So I'm going to convert it into interval form. So minus 2 to 2, open interval, minus 2 to 2 is represented by minus 2x less than minus 2 greater than x less than 2 can be denoted by in the interval form as open interval minus 2 comma 2. Okay. So here first I am going to let it name it as equation number 1 and this equation number 2. Okay, so we get the whole the domain of this function and this function. So in this question we need to find out the domain of whole function. So if we observe these two intervals, the common elements in these two intervals are the domain of our whole function. So we get here first part is minus infinity to 8 and second function domain is open interval minus 2 comma 2. Okay, so in these two interval, minus infinity to minus 2 are common, right? Minus infinity to minus 2 are common. Minus 2 are common. And from this 2 to 8 are common. 2 to 8 are common. 8 are common. Here or is present, so we have already learned in sets or means union, right? The word or means union. So the elements of these two intervals are the domain of our whole function. So next I am going to place a union here. That is, our x is a element of or domain x lies between the interval containing minus infinity to minus 2 and 2 to 8. Okay, so in this question, first we need to find out the domain of each term. Next we need to note that the common elements from these two intervals, and that elements are the domain of our whole function. Okay, I hope you understood. In this question, find the domain of the function f given by f of x equal to 1 divided by root of greatest integer x square minus greatest integer x minus 12, where this term denotes the greatest integer function. Okay, when we have already learned that greatest integer function is denoted by this, and the greatest integer x means the greatest integer less than or equal to x, right? The greatest integer less than or equal to x. I hope you remember. So let's start the solution of this question. Here in this question we need to find out the domain of this function. So this is a domain of a fraction. So we know that a fraction in a fraction the denominator term cannot be equal to 0, right? So the denominator term here is root of greatest integer square minus greatest integer root of greatest integer x square minus greatest integer x minus 12. And we know that a root term is always greater than or equal to 0. But here this term is present in denominator. So we cannot write equal to term here. Only write greater than 0. So this term is always greater than 0 in this function. Okay. So next taking square on both sides, we get greatest integer square my x square minus greatest integer x minus 12 greater than 0. 0 square is 0, right? Okay. So we know that x square minus x minus 12. This is a quadratic equation equal to, if this term equal to 0, we have already learned a identity that x plus a into x plus b equal to x square plus a plus b into x plus ab. Right. So note that this coefficient of x, here coefficient of x is minus 1 and constant term that the term which is independent of x. So here if you observe this quadratic equation or this equation, the constant term is minus 12. So comparing these two terms, here a plus b is the coefficient of x, right? So comparing these two terms, we get a plus b equal to minus 1 and ab equal to minus 12. And we know that if we adding two number and we get a minus 1, and if we multiply two number and we get minus 12, the numbers are minus 4 and 3. So if we add minus 4 and 3, we get minus 1, and if we multiply minus 4 into 3, we get minus 12. So we can write it as x minus 4 into x plus 3. This is equal to x square minus x minus 12. Okay. So either if we write x square minus x minus 12 or x minus 4 into x plus 3, we get the both same values. Okay. So comparing these two terms, here x is replaced by this greatest integer x, we get the same value. So replacing this x by greatest integer x, we can write as greatest integer x minus 4 into greatest integer x plus 3 greater than 0. So this term can be written as this way. I hope you understood. Okay. So either this term is greater than 0 or this term is greater than 0. Okay. From this we get greatest integer x greater than, minus, taking this minus 4 to RHS, it will become 4. And this term greatest integer greater than, taking this minus 3 to RHS, we get greatest integer greater than minus 3. Okay. Okay, so next I'm going to convert it into intervals. Great. So this term converting into interval, the greatest integer x greater than 4 means the element x lies in the interval, open interval 4 to infinity. And again the greatest integer x greater than minus 3 means the value of x lies between the interval minus infinity to minus 3. So rearranging this interval minus infinity to minus 3 or 4 to infinity are the domain of this function. So if we observe these two intervals, there is no common elements are there. So we can write it as our domain of the whole function is minus infinity to minus 3, open interval minus infinity to minus 3, union 4 comma, open interval 4 comma infinity. Okay, I hope you understood. This is our third question. If f of x equal to y equal to 4x minus 5 divided by 9x minus 4, we need to prove that f of y equal to x. So let's start the solution of this question. Given that f of x equal to y equal to 4x minus y divided by 9x minus 4. Okay, so here we know that generally f of x can be denoted as y, right? So in this question, y equal to, again both are same, 4x minus 5 divided by 9x minus 4, right? If f of x is 4x minus 5 divided by 9x minus 4, then f of y become 4y minus 5 divided by 9y minus 4. So substituting the value of y in this equation, here y is 4x minus 5 divided by 9x minus 4, we have already given in the question. So substituting the value of y in f of y, that is 4 into y is 4x minus 5 divided by 9x minus 4 minus 5 whole divided by 9 into 4x minus 5 divided by 9x minus 4 minus 4. Okay, next I am going to cross multiplying. In the denominator we get 4 into 4x minus 5 minus 5 into 9x minus 4, that is this 4 into this term and 5 into 9x minus 4 divided by 9x minus 4 whole divided by, on the denominator again I am going to cross multiplying the whole term. We get 9 into 4x minus 5 into 4x minus 5 minus 4 into 9x minus 4 whole divided by 9x minus 4. So if you observe here, these two terms are common and cancel each other. And we get open this bracket 16x minus 20 minus 5 into 9x means it will become 45x, and minus 5 into minus 4 become plus 20 whole divided by 9 into 4x, that is 36x, minus 9 into 5 means 45 minus 4 into 9x means minus 36x, and minus 4 into minus 4 become plus 16. Okay, here on the numerator this plus 20 and minus 20 will cancel each other, and again on the denominator this minus 36 and plus 36 will cancel each other, and here we get 16x minus 14x, 16x minus 45x, right? 16x minus 45x on numerator, and on denominator we get 16 minus 45. Taking this x is common, right? X is common in numerator, so taking this x outside we get x into 16 minus 45 in numerator, and on denominator 16 minus 45. These two terms are common and cancel each other, and we get x here. So we have shown that f of y equal to x. Okay, I hope you understood. This is our next question. Let A equal to set of all elements containing 9, 10, 11, 12, 13, and let f is a function from A to natural number be defined by f of n equal to the highest prime factor of n. Find the range of f. Okay, so let's start the solution of this question. Given that A is a set containing elements 9, 10, 11, 12, 13, and f is a function from A to natural number, right? And is defined as f of n equal to our function f of n equal to the highest prime factor of n. So first I'm going to take this 9. So the factors of 9. The factors of 9 are 1 and 3 and 9. Okay, so next we need to find out the prime numbers of the factors of 9 that are 3 only, right? So that's why I write 3 here. The prime factor of 9 is 3. Next I am going to write the factors of 10 is 1, 2, 5 and 10, and from this we need to find the prime factors of 10 is 2 and 5. That is, prime number in the factors of 10 are 2 and 5. So I write 2 and 5 here. Next we need to find out the factors of 11 that are 1 and 11, right? So in these factors of 11 the prime number is 11, so that's why I write the prime factor of 11 is 11 here. Next we need to find the factors of 12 that are 1, 2, 3, 4, 6 and last is 12. Okay, so from this the prime numbers are 2 and 3, right? So the prime factors of 12 are 2 and 3. Next we need to find out the the factors of 13. The factors of 13 is 1 and 13. In this the prime number is 30 only. So the prime factors of 13 is 13. Okay. So here the function is defined as the highest prime factor of n. So first of all I'm going to find out the f of 9. So here n is 9. So comparing these two, here n is 9. So the highest prime factor of 9 is the prime factor of 9 is 3. 3 only. So the highest prime factor of 9 is 3. Right. Next we need to find out f of 10, that is the highest prime factor of 10. So comparing these two terms, here 5 is higher value. So that's why I write 5 here. Okay. Next we need to find out f of 11. Here the prime factor of 11 is 11 only. That's why I write 11 here. The highest prime factor of 11 is 11. Next the higher f of 12, the highest prime factor of 12, here 2 and 3, the higher value is 3. So the highest prime factor of 12 is 3. Next prime factor of 13 is 13. So f of 13 means the highest prime factor of 13 is 13 only. Okay, so next I'm going to write our function as our ordered pair is a set of all ordered pair is 9 3. First ordered pair is 9 3. Second ordered pair is 10 5. 10 5. Third ordered pair is 11 11 11 comma 11, and fourth ordered pair is 12 3. 12 comma 3, and fifth ordered pair is 13 13. 13 comma 13. So if you observe the question, we need to find out the range of the function. So now here it is the function of the function, and we need to find out the range of the function, and we know that the range of a function is set of all second element of the function is called range. So from this we can write 3 5 11 3 and 13. So the common elements are right only once. So therefore the range of function is 3, the set containing 3 5 11 and 13. Okay, I hope you understood. This is our last question. Let F be the subset of Cartesian product Z cross Z defined by F is equal to set of all ordered pair AB, A plus B such that A, B is an element of Z. We know that Z is set of all integer, right? Is F a function from Z to Z? And we need to justify our answer too. So in this question, we need to check whether the given relation are as a function or not. Okay, so let's start the solution of this question. So we know that a relation f from a to b is said to be a function if every element of set b, every element of set A has unique images in set B, or no two distinct ordered pair have same first element. Right. So given that our function is defined, our relation is defined set of all ordered pair AB, A plus B such that A, B is an element of integer. Right. So let us take 2, 6, minus 2 and minus 6 is an element of Z. Okay. So let us substitute the values of A, B here. So let us first take here A, B as ordered pair 2, 6, and next take ordered pair as minus 2, minus 6. So we get the function value as AB means 2 into 6, right? 2 into 6, comma. A plus B means 2 plus 6. And also our function contain, if we take this ordered pair, here AB means minus 2 into minus 6 and A plus B means minus 2 plus minus 6. Right? And these two elements are elements of our function. Okay, so here we get sorry, here this element is function of f, and here this ordered pair is element of f, function f. So here we get 12 comma 8 is element of f, and here also we get minus 2 into minus 6 is 12, right? 12 comma minus 8 is element of f. That is our relation. So this relation or this ordered pair containing our relation. So if we observe these two ordered pair, it can be seen that the same first element, that is 12, corresponding to two different images, that is 8 and minus 8. So we can say that the relation f is not a function. Okay, so we can see that the same first element, that is 12, corresponds to two different images, that is 8 and minus 8. Therefore we can say that the relation f is not a function. I hope you understood the question clearly.